Hi guys, so we're back in 5.2 still is induced EMF in a straight conductor. Okay, so this is the explanation how I get the equation. So kita ada phi, which is magnetic flux, equals to BA cos theta. So by this one we submit theta as 0 lah. So it means that B and A are parallel to each other. So A equal to Lx, phi equal to BLx. Then induced EMF equal to dphi over dt. So kita set everything, kita dapat lah. So this will be equation for induced EMF in a straight conductor. So theta will be the angle between V and B. Okay, so L will be the length of conductor. Okay, so this is the magnitude of induced EMF. How to determine the directions of induced EMF? So you can see down here. So to determine the directions of induced EMF, same as before, we're going to use the right hand grid rule. Okay, so kalau kita tengok dalam Lenz's law punya flow chart, first of all we got to determine directions of external magnetic field. So if you look at the example here, so it's X, so X is means the external magnetic field is going into the page. Okay, so as we're moving our straight conductor to the right, we're moving to the right means that, so for example it's moved to here. Okay, so what happened to the magnetic flux? Okay, previously there is a 4 magnetic flux. Okay, then when it moves to the right, it goes to this point up here. So the total magnetic flux will be, sorry, tadi ada 1, 2, 3, 4, 5, 6. Now we got 1, 2, 3, 4, 5, 6, 7, 8. Means that the flux will increase. Okay, bila flux increase means that the induced EMF which try to oppose the changes will be in out of the page, opposite direction. Okay, sebab dia nak cancel yang ni, so dia jadi out of the page. So now next kita akan guna right hand grip rule. Okay, so right hand grip rule, kita akan make sure that your finger, your thumb will be in the directions of induced magnetic field, which is out of the page. Okay, your thumb must within this area, kawasan ini sahaja. Then you gotta curl your finger and the directions of induced EMF follows the curl of your fingers. Okay, for this kind of question it's quite easy because there's a loop. If there's no loop, you gotta make a loop on yourself. Okay, well that's about it. So this is the example for the applications of induced EMF in a straight conductor. So you are given the rod of length of 1.5 meter, move perpendicularly to uniform magnetic field. So you got a B there. Line, you're given the line is 1.5 meter. Magnetic field is 0.7 Tesla. Speed is 25 meter per second. Okay, if the resistance of the wire is 7 ohm, I'm going to find the induced current. Right? So to be able to find the induced current, kita akan guna induced EMF equal to induced current times resistance. So I induce equal induced EMF over R. It means that first of all going to find the induced EMF. Okay, so because we are given the rod, means that it's a straight conductor. How else we need to use which equation? So because we're given the speed, mesti akan guna BLV, induced EMF equal to BLV sin theta. So we got a B here 0.7, length will be 1.5 meter, velocity 25. How about the theta? Okay, because it state that kita ada conductor like this, we have a conductor. Okay, kata conductor is moving perpendicular to uniform magnetic field. So if we say it's moving to the right like this, so magnetic field will be perpendicular lah. So be the angle between these two will be 90 degree. So sin 90. So here you're going to get 26.25 volt. Next step, so calculate the induced current, induced EMF 26.25 over resistance in the wire, bagi dengan 7. Then you get 3.75 ampere. Okay, because the question asks you to calculate the magnitude, no need to write down to find the current, directions of the current.